What's up guys, and in today's video we're going to be looking at how to derive the compound angle formula for cosine and then how we can utilize this to solve some questions. So the first thing here is you can see I've got a unit circle and I've labelled points A, B and C, and the segment AB, or the chords AB, I've labelled AB. Now we should know that in the unit circle, for each place on the circle, the x and y coordinates are simply cos B as the x and sine B as the y, and that is the same for A, which is cos A sine A. Yep. And the next thing I want to try and find is this angle here. So we know that I've labelled point B here. That must mean the angle from here to this segment, which is in line with point B, must have angle B. And that goes for the same with point A. It must mean it's A degrees anti-clockwise around the unit circle. So therefore, this angle here is simply A minus B. So now we can use that information to attempt to derive the compound angle formula. So the first thing I want to do is find this length A and B two ways, and I'm going to do that using the cosine rule and also the distance formula. So the first thing I'm going to do is utilize the cosine rule. So we know this has been written in terms of a side length oh sorry, that's cos C, and that is 2BA. And C squared in this case is the line opposite point C, which is simply AB. So that means AB squared equals A squared, which is simply 1, because we know it's a unit circle, and that's the same with BC. So B is also 1, and then we're subtracting 2 times cos of this angle C, which is A minus B. And then if we simplify that, we get AB squared equals 2 minus 2 cos A minus B. So that's one part of the equation. The next way we're going to do this is by using the distance formula between point A and point B. So that means AB squared will equal cos of A minus cos B squared, plus sine A minus sine B squared. Now if we expand that, we get AB squared equals cos squared A plus cos squared B minus 2BC, minus 2 cos A cos B. Alright, a little messy, but and then expanding the sign brackets, we get plus sine squared A plus sine squared B minus 2 sine A sine B. That's a little messy, but anyway. Now we can see that we've got a cos squared A and a sine squared A, and we know that's just going to equal 1. And we've also got a cos squared B and sine squared B, which is just going to equal 1. So therefore, AB squared also equals 2 minus 2 cos A cos B minus 2 sine A sine B. And as you can see, we've also got here another expression for AB squared, so we're just going to equate them. So therefore 2 minus 2 sine A sine B minus 2 cos A cos B will equal 2 minus 2 cos A minus B. There we are. And if we simplify this, the 2's cancel, and we can divide everything by -2, which simply leaves us with sine A sine B plus cos A cos B will equal cos of A minus B. And that's the compound angle formula. Now we can change this for plus, so the compound formula for A plus B. So we'll do that now. Let's let B equal -B. So that means that cos of A plus B will equal cos A. And we know that cos of minus B is just simply just going to be B, because it's going to be in the 4th quadrant. So that remains cos of B. But now it's going to be negative sine A sine B, because if we move B negative into the 4th quadrant, sine is negative, so therefore sine B is negative. So that's the formula for the compound angle identity for A plus B. Now we're going to have a look at how we can use this information to solve some practice equations. So the first one I want to have a look at is cos pi on 12. Now, using the compound angle formula, which I'm going to write here as cos A minus B equals cos A cos B plus sine A sine B, we can express this fraction in terms of 2. And if we do that, we get cos of pi on 3 minus pi on 4. Notice how pi on 3 minus pi on 4 is just pi on 12. Now with this, we can use this equation where we sub in A is pi on 3 and B is pi on 4. So this is going to equal cos pi on 3 cos pi on 4 plus sine pi on 3 sine pi on 4. And now you can see that these are all values that we know the exact value for. So we know that pi on 3 is simply a half, or cos pi on 3 is a half, and then cos pi on 4 is 1 on root 2, plus sine of pi on 3 is root 3 on 2, and then sine of pi on 4 is again just 1 on 2, and if we simplify that, 1 on root 2, simplify that, we get 1 on 2 root 2 plus root 3 on 2 root 2, and then that simply equals root 3 plus 1 on 2 root 2, and then of course if you want to rationalize the denominator, times each by root 2 as such, and then that will simply equal root 6 plus root 2 on 4. So we'll have a look at one last equation of using this formula, and to do that we're going to have a look at cos of 75 degrees, and how we can find the exact value for this. Now, for this one, we're going to split it up into an addition. So 30 degrees plus 45 degrees. As you can see, that simply equals 75 degrees. So this time we're going to sub it into the equation, which is going to look a little bit different. Will equal cos 30 cos 45, and it's going to be minus this time instead of plus, minus sine 30 sine 45. And again, these are all values that we know the exact value for, so we can just sub it in. So cos of 45 is 1 on root 2, cos of 30 is root 3 on 2, minus sine 30, which is simply a half, and sine 45, which is 1 on root 2. And if we simplify this, we get root 3 on 2 root 2 minus 1 on 2 root 2. Now we can simply simplify this and we get root 3 minus 1 on 2 root 2. And that is the exact value for cos of 75 degrees. Thank you.